Hello everyone, myself Dr. Ranjith Kumar Gatla, working as an Associate Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering. In today's class, we are going to discuss the topic which is equivalent resistance. So, which means how to find the equivalent resistance across the two terminals in a given circuit. So, we have already discussed, how to identify whether the two resistors are in series or parallel combination. So here, once again, let me just give you an idea about how to identify the two resistors are in series and parallel. So as we know, if the two elements are connected in series, so then the current flowing through these elements are, especially in terms of when we consider only the resistance. So if the two resistors are connected in series, then the current flowing through the two resistors is same, because as we know, the current flowing through the series elements is same. And similarly, when the two resistors are connected in parallel, then the voltage across the two resistors is same, because the voltage is nothing but the potential difference across the 2 points, and here the two resistors are connected across those two common points. So that's why the voltage across the two resistors connected in parallel is same. Then before going to solve this problem, so first of all, we should identify whether the two resistors are more resistors connected in series or parallel. So for that, the condition is, suppose for the two resistors are in parallel, then the two resistors must have only one common point, and that common point should not share with any other element. Either it may be other resistor, or it may other inductor or other capacitor, or it may be the active energy source, okay, which means either it may be current source or voltage source. So the condition to make the two resistors are in series is the two resistors must have only one common point, and that common point should not share with any other element, right? So here, for this given problem, as you can see here, so we need to find the equivalent resistance between the two terminals. So let us call here the terminals are A and B. So we have to find the equivalent resistance between the terminals A and B. Then here, let us start from this side. So here first we need to identify, okay, so here the 4 ohms and 5 ohms and 3 ohms are there. Okay, first let us go with the 4 and 5 ohms. So here these 4 ohms and 5 ohms resistor having only one common point. This is, let us consider the common point. And this common point is not connected to any other element, right? Because here this common point is connected to only the 4 ohms resistor and the 5 ohms resistor. Then we can say these two are in series, right? Then these two will be represented by the equivalent resistance. Okay. Then again we need to draw the same circuit. Okay. So for the first problem, I am just doing as it is. So here then the equivalent circuit must be, here of course again the same resistors we should draw as it is. Then here this one, and again here this you will be having. So here it is 4 ohms and here it is 3 ohms. Again here it is 6 ohms and here it is 4 ohms and then 3 ohms, and again here there is no resistor. Then here 4 and 3 are in series. Then these two resistors, okay, so because these two resistors are in between these two terminals, so in these two terminals we are replacing one equivalent resistance, right? Okay, so just let us draw. Okay, here of course again you will be having here the 3 ohms resistor. Then in these two terminals you are having one equivalent resistor. So then if the two resistors are in series, then the equivalent resistance must be, then R equivalent is equal to here RA plus RB. So let us consider here it is RA and here it is RB. So then here R equivalent is equal to, RA is here 4 plus 5 which is equal to 9 ohms. So then here it is 9 ohms and here it is 3 ohms. Then again if you see here, these 9 ohms and these 3 ohms are having only one common point, which means here these two are in series, right? Then if these two are in series, then we should replace across which terminals? These two terminals, okay. So these two terminals as an equivalent resistance. Okay. So 9 plus 3, again here it is 12. Then here I am just replacing here, as you can see. So this can be replaced with here, what is that? 12 ohms. Otherwise, okay, in simply, as you can see here, these three, directly you can write these three are in series. Okay, because here, these two having one common point, and again the combination also having one common point. So that's why these three are in series. So 4 plus 5, 9, 9 plus 3, 12. So that's why here 12 ohms. Then again here, these 12 ohms and these 4 ohms are in series or parallel. Okay. So let us come with here, because here this node and this node, okay, and this node and this node are same. So which means here these 4 ohms and 12 ohms are having two common nodes. Okay. Of course, when coming to the parallel condition, the two resistors must have two common nodes. That is enough. Okay. So whether that common node is sharing with another element or not, here it is not a point. So whether the two resistors having two common nodes or not, that is the point here. So if the two resistors having the two common nodes, then those two are in the parallel. So that's why, of course, here these two resistors having two common nodes. Let us consider here the common node, which is here it is A and here it is B. Okay, don't think like this is one common node and this is another common node, because in these 2 points there is no element. So that's why these two nodes are same. So that's why combinedly I am just naming it as A, and here it is a B. So of course these two resistors having two common nodes, then parallel. So in this case, of course, if there are two resistors, then R equivalent is equal to RA RB by RA plus RB. R, in other words, here 1 by R equivalent is equal to 1 by R1, the reciprocity of the reciprocal of the two resistors. Of course, if you simplify this, then you will get this one only. Okay, sorry, RA RB here we are considering. Then here, then the equivalent resistance here it is 4 into 12 by 4 plus 12. Then here 4 into 12 divided by here 4 plus 12, which is 16. So the answer is, here it is 3 ohms. Right. Then the equivalent circuit will be, again here it is 4 ohms, and here it is 3 ohms, and again here it is 3 ohms, and of course here it is 6 ohms. Then here there is no resistor, and this combination will be replaced with another equivalent resistor, and that equivalent resistance value here it is 3 ohms, and again here this 3 ohms is there, and again here it is 6 ohms, and here it is 3 ohms, and here it is 4 ohms. Then now you can see here these 3 ohms and 3 ohms are in series, because these two are having only one common point, because this point here it is and this point here it is. So that's why here 3 are having only one common point. Then we can replace this with an again equivalent circuit. Okay, so this equivalent circuit must be here this one, and here it is 6, and again here it is 3, and this 3 plus 3 you can replace it as a, again here it is 6 ohms, and here it is 6 ohms. Okay, and again here it is 4 ohms, and here it is 3 ohms. Then again here these two are in parallel, because here these two are having again one common node, and here it is another common node A and B. Okay, so then here it is 6 into 6 by 6 plus 6. Okay, so then 36 by 12. Okay, so here it is 6 into 6 divided by 12. So here it is 3. Right. So then this circuit will become 4, and again here the 6 and 6 will become 3. Okay, here it is 4 ohms, and here it is 3 ohms, and again here it is 3 ohms. So here these are the two terminals. We have to find the equivalent resistance between these two terminals. Then as you can see here, in another words, we can just write this one. Okay, redraw this one like this. So here it is A, and here it is B, and 4 ohms, 3 ohms, and again 3 ohms. So as you can see here, 4, 3, 3 are in series. Then the equivalent resistance here, let us consider here RAB, which is equal to 4 plus 3 plus 2. So which is 9 ohms. So this is the way to find the equivalent resistance between the two terminals. Right? Then let us go with another problem. So here it is very simple. Here 1 ohm and 1 kilo ohm, these two are in series because having only one common node. So then the equivalent circuit here you will get here if you replace this 1 plus 1 2. So again here it is 1 ohm is there, and here it is there is no resistance, and here it is 1, and here it is 1 again, and here it is 2 again. Then these two are in what is that series. Then the series combination here you can write here. So of course here it is 1 kilo ohm and again 1 kilo ohm. So here it is 2 kilo ohm and 2 kilo ohm, and here it is 1 kilo ohm. Okay, sorry, 2 kilo ohm. Right? So here it is 2 kilo ohm. Now again here these 2 kilo ohm and 2 kilo ohm are in parallel. So 2 kilo ohm are parallel with this 2 kilo ohm. Then the resultant here it is 2 into 2 by 2 plus 2. Okay. So then here it is 4 by 4. So which is equal to again 1 ohm. Right. Then here again you can just draw here 1 ohm, and here it is 1 ohm, and here you will be having again 2 ohm. Okay. And here you will be having 1 ohm, and here you will be having again 1 kilo ohm. So 1 kilo ohm, and this is 2 kilo ohm. So here it is 1 kilo ohm, and here of course there is no resistor here. This is the equivalent circuit. Then again here these 1 and 1 are in series. Then again the equivalent circuit will be here like this. So here it is 2 kilo ohm, and here it is 2 kilo ohm, and here it is 1 kilo ohm. Then again here these 2 and 2 are in parallel. Okay. Then here 2 into 2 by 2 plus 2. So which is again 1 kilo ohm. Then the finally equivalent circuit will become here like this. So here let us consider A and B terminals, and here also A and here also B terminals. So here 1 kilo ohm and 1 kilo ohm. So finally here the RAB, which is equal to 1 plus 1, which is equal to 2 kilo ohm. Right? So here, even without doing all these things, okay, I will just let you know very the simple technique. Okay, so without drawing this, how we can find the value, because here very easy values that they have given. Okay, so here 2, 2 and all are 1. So let us draw again here the circuit, and here you will be having one more. Okay, and here you will be having one more, and of course here one resistor, and here one resistor, and here one resistor. Right? So this is the way that here. So here it is 2 kilo ohm and 2 kilo ohm and 1 kilo ohm, 1 kilo ohm, and again here it is 1 kilo ohm, and here also 1 kilo ohm. So we need to find the resistance across these two terminals A and B. Right? So here as you can see 1 and 1 series. Okay. Then the series is combination is in parallel with the 2. Fine. So here 1 is in series with 1, then 2. Then here 2 is in parallel with 2, then you will get again 1. Then here this 1 again in series with 1, so 1 plus 1 again, here it is 2. Okay. And again here these 2 and these 2 are in parallel, then 2 to parallel, again you will get 1. Then 1, 1, then 1 plus 1, then 2. Then this is the final answer. Because if any resistors having the same value are in parallel, okay, then the equivalent resistance must be R by 2. R by 2. Because of course here R1, R2 by R1 plus R2. Okay. So if you take R1, R2 values as same, okay, then what you will be having here R1 and here also R1. Okay. Let us consider. Okay. R in anything. Okay. And here what is that? Here R plus, okay, of course here R1 plus R1, let us consider. When R1 is equal to R2, okay, then here it is R1 square by here it is 2 R1. Okay, so R1 gets cancelled, then 1 by 2 into R1. So which means R1 by 2. That's what. So if suppose let us consider 11 ohms resistor in parallel with the 11 ohms resistor, then you will get 11 ohms, the equivalent resistance. Sorry, 11 by 2, right? Okay. So 11 by 2 here, 5.5 ohms that you will get. So like that, some small tricks we need to know, okay, to find the equivalent resistance between the two terminals very quickly, right? Right. So now, of course, some more a little complex problem. This is also easy, but when compared to the previous problem, here this is a little complex circuit. So in this circuit also, we need to find the equivalent resistance between the A and B terminals. So which means here we need to find RAB. Okay, RAB. So here according, it is up to us, like if you want to find the equivalent resistance between the C and D terminals also is okay. Of course, here A and A, C, E, okay, because A is equal to C is equal to E terminal, okay, and similarly here B is equal to D is equal to F, right? So like this you will be having, right? Then now here as you can see, these 4 ohms, 6 ohms and 12 ohms. Okay, these three are in parallel because all these three resistors having only two terminals, the two common terminals. So that's why we can make it these three are in parallel. Okay, so if these three are in parallel, then R 2 by 2 just we can consider. So first 4 and 6 are in parallel. Okay, then this combination is parallel with the 12 ohms. Then in this case here, how to find here it is. So of course 4, or we can write like this. Okay, 4 into 6 by 4 plus 6. This is one combination, and this into 12 by, so 4 into 6 by 4 plus 6 plus 12, right? Then if you simplify this, so first let us find here this 4 into 6 divided by 4 plus 6, here it is 10. Okay, then you will be having the answer 2.4. So which means here 2.4 into 12 by 2.4 plus 12, right? Then into 12 divided by, here 2.4 plus 12, here it is 14.4. Then the answer here it is 2 ohms, right? Then we can replace this total 3 resistors with an equivalent resistance of the 2 ohms. Then the circuit will become here, yes, of course, that is one thing. And another thing also we can do here, again here these 5 ohms and 20 ohms are also in parallel because these two are having the two common nodes. Okay, then this will become here 5 into 20 by 5 plus 20, right? Then here 5 into 20, okay, yeah, 5 into 20 divided by, here 5 plus 20, here it is 25. Then you will be getting the 60 ohms. Okay, so then, sorry, here not 60. So here 5 into 20, 5 into 20 and divided by, here it is 25. Then you will be having 4 ohms. Anyway, if the two resistors are in parallel, then definitely you will get the reduced resistance value. So then this can be also replaced with 4 ohms, and this 3 can be replaced with, here it is 2 ohms. Then the equivalent circuit will become here 1 ohm as it is, and again 3 ohms as it is, and this 3 combination is replaced with 1 resistor. Okay, and again here this 2 ohms is as it is, and this resistor can be replaced with the equivalent resistance value. So here it is 1 ohm, and here it is 3 ohm, and here it is again the combination is 2 ohms, and here it is 2 ohms, and here the combination that you are getting is 4 ohms. again the terminal, here it is A and here it is B, okay, C, E, D and F, right? Then here these three are in series and again these two are in series. So if these three are in series, then 1 plus 3 plus 2, okay, which is 6. And here these two are in series, then 2 plus 4, which is equal to again 6. Then the equivalent circuit will become like this. So here it is 6 ohms. And here also it is 6 ohms. Okay. Then again here it is A and B. Then 6 and 6 are in parallel. Then what is the equivalent resistance according to the previous technique? Here it is 6 by 2, so 3 ohms. Then here RAB, which is equal to, in between A and B, here it is equal to 3 ohms. So this is how we need to, we can find the equivalent resistance between the any two terminals of a given circuit, right? Then let us discuss another problem, right? So this is also very simple, as you can see. Here, of course, again we have to find in between these two terminals. Okay, then let us start with from the right hand side. So here, of course, here the 10 ohms and 10 ohms and here 2 ohms. Okay, 10 ohms and 2 ohms are in a series. Then you will be get, okay. So across these two, okay, let us draw here. You will be having one equivalent resistance. So here 10 plus 2, which is equal to 12 ohms. Then these 12 ohms and 6 ohms. Okay, then these 12 ohms and these 6 ohms. Okay, the 6 ohms are in parallel, right? Then this will become here 12 into 6 by 12 plus 6. Okay, then here this value, here it is 12 into 6 divided by 12 plus 6, here it is 18. Then you will be get 4 ohms resistance, right? Then here these 4 ohms, the equivalent 4 ohms and this 8 ohms are in series. Okay, 4 ohms and 8 ohms are in series. Let me draw again here. So because without getting confused, right? So the circuit up to here I'm just drawing as it is. And here one more resistor is there. So here these two can be replaced with 4 ohms. Okay, this is is as it is. And here this will become 4 ohms. And here it is again 8 ohms. And here it is again 6 ohms. Okay. So I'm not writing all these resistors because having the same. So now as you can see, here these 4 ohms and 8 ohms are in series. Okay. Then this can be replaced with 8 plus 4, which is again 12 ohms. Right. Then I'm just replacing this circuit, okay, with the equivalent resistance. Here that equivalent resistance, here it is 12 ohms. And again, as you can see here, these 12 ohms and these 6 ohms are in parallel. So just now we have seen the 12 ohms and 6 ohms are in parallel, then the equivalent resistance will be the 4 ohms. Then we can replace this total circuit with the, the equivalent resistance of the 4 ohms. So just I'm replacing here, as you can see, here it is 4 ohms. And of course, here what is the value? Again, here it is 4 ohms and here it is 8 ohms and here it is 4 ohms. Then as you can see here, these 4 and 4, these 4 ohms and 4 ohms are in series because only having one common node. Then the equivalent resistance will be 4 plus 4, okay, so which is equal to 8 ohms, right? Then again, I am replacing these two with the 8 ohms here. Like this, so here it is 8 ohms. Now these 8 ohms and again these 8 ohms are in parallel because having the two common nodes. This is again one common node and this is the second common node. Then here 8 and 8 are in parallel, then the equivalent resistance must be 4 ohms, right? Okay. Then here these two must be replaced with one equivalent resistance. Okay. Then here just let me replace here this one with 4 ohms resistor. Then again here these 4, of course here it is again 8 ohms resistor. And again, these 4 and 4, these 4 and 4 are in series because here it is where we will be having only one common node. Then these 4 can be replaced with 8 ohms because 4 plus 4, these two are in series. Okay, so let me replace here it is 8 ohms. Again here this 8 and this 8 are in parallel because having the two common nodes. This is 1, okay, and this is 2. So then here 8 into 8 by 8 plus 8, okay. So otherwise R by 2, which is equal to again 4 ohms. So let me replace this with the 4 ohms, right? So this is then 4 ohms. And again here you will be having 6 ohms. Now these 4 and 6 are in parallel, 4 and 6 are in series because having only one common node. So here 6 plus 4, which is equal to 10. Then here the equivalent resistance RAB, which is equal to 10 ohms. So this is the way to solve the problem. Very simple, right? Right. Then, yeah, as you can see, because as of now we have seen a kind of circuits. The left hand side terminals, we need to find the equivalent resistance between the left hand side terminals. Then what is that? We started from the right hand side. Now here the terminals are here inside the circuit. So we have to find the resistance between these two terminals. Then how to find the resistance between these two terminals? So first of all, one important point that we should remember is we should not disturb the terminals. Okay, in between which terminals we are going to find the equivalent resistance. Okay, that's why we should not eliminate those two terminals, right? Yeah. Then now here, as you can see, at one step we can reduce many things. Okay, so here this are in series. So here 3 plus 3, which is equal to 6 ohms. And again here these two also are in series. So 3 plus 3, which is equal to, again here it is 6 ohms. And again same way these two, here 3 plus 3, here it is equal to again 6 ohms. And again here it is 3 plus 3, here it is equal to also 6 ohms. So now all these 4 can be replaced with the 6 ohms. Now the circuit will become, of course here I'm just drawing again the same way, here 1 and 2. Right here it is one more is there. And here it is one more is there. So this is the terminal A and this is the terminal B. So A and B. So in between these two can be replaced with one resistor. Okay. So here it is 6 ohms. And these two can be also replaced with one resistor. Here it is 6 ohms. And these two can be also, here it is 6 ohms. Sorry, not these two. These two. Here it is 6 ohms. And again these two also. Here it is 6 ohms. Right. So now I'm just drawing here 1 and here 2. Here 3, here 4. Then this circuit will become like this. So of course here it is again 4 kilo ohms and here it is again 4 kilo ohms. Of course here it is K because 3 plus 3 kilo ohms, right? Then here it is 6 kilo ohms and here it is 6 kilo ohms and here also it is 6 kilo ohms and here also it is 6 kilo ohms. And here it is the terminal B. Okay, like this, let us consider the same, right? Then now, how to, because here, as you can see here, these two are connected because here these all are, because this terminal, and this terminal are same, right? Then in this case, how to find the equivalent resistance between these two terminals, right? As you can see here. Now the another combination is here, you can see. So let us see here, let us see here whether these 6 ohms and 4 ohms are series or parallel. Of course here 6 and 4 having one common point, but this common point is sharing with again this 6 kilo ohm resistor. So that's why we can't say these two are in series. Okay, let us consider whether these two are in parallel. Okay, of course, here as you can see, these two are in parallel. Why? Because, okay, these two are having two common nodes, right? So what are those two common nodes here? This is one common node, okay, and another one is this. This is the second common node, because this point and this point is same. Similarly, here 6 ohms and 4 ohms are also again having in parallel, because this is one common node, okay, and again this is the second common node. So that's why now you can replace with these two and these two, okay, these two combinations are in parallel and these two combinations are in parallel, and again these all combinations are in series with, okay, then here this circuit will become, of course, here let us find here which is 6 into 4 divided by 6 plus 4 10, so which is equal to 2.4, right? Because 6 into 4 24 by 6 plus 4 10, so here it is 2.4. Then this circuit will become here, because here it is in between 1 and 2 terminal. Okay, let us consider 1 1 and 2, or in another words, let me draw these terminal names as here it is 1, okay, here it is 2, and in between here it is, let us consider here it is 3, right? So in 1 and 3, in 1 and 3, okay, so there is one resistor. This resistance value is here it is 2.4 kilo ohm, and again this is 1 and this is 3, and in between 3 and 4 also again here these 6 ohms and 4 ohms are in what is that series, in parallel. Then again here you will be having one more resistance, again here also it is 2.4 kilo ohm, right? So what is this terminal? This terminal again here it is, let us consider here it is A, okay, and here it is again B, and again here in between 1 and 2 3, let us consider here it is 4. So in between 1 and 4 again there is another resistor which is 6 ohms, 6 kilo ohms, and again in between these two also there is another resistor, this is again 6 kilo ohms, right? Now this is the circuit. So now you can see these, because now where we need to find in between these two terminals, okay. So now here 2.4 and 6, and even these 6 and 2.4 are in parallel, because these 2.4 and 6 having only one common node, and here these 2.4 and 6 again are having only one common node, right? So that's why these two are in series and these two are in series, okay. Then the equivalent circuit must be, so of course again here it is A and here it is B, okay. So here in between you will be having one resistor, and in between you will be having another resistor, okay. So here what are these values? Here 2.4 plus 6, here it is 8.4 kilo ohms, and here also it is 8.4 kilo ohms, and here it is A and B. So again here 8.4 are in parallel, because having the two common points. Then here this will become, of course, 8.4 in parallel, then 8.4 divided by 2, then you will be having, here it is 4.2. So then RAB, which is equal to 4.2 kilo ohms. So this is how we can find, we need to find the equivalent resistance, right? So here the key point is, okay, here these 3 points are same, okay, that we need to identify, otherwise it is very difficult to solve this problem, okay. This point and this point and this point all are same, okay. So here all are representing, here this is also point A and this is also point A and this is also point A, okay. So that's why here these two resistors are having only two common nodes, and these two resistors also having two common nodes, so the combination can be replaced with the 2.4 ohms, right? Then now this one, this is again very simple, right? So these 15 ohms and 10 ohms are in series, so 15 plus 10, which is equal to 25, and so which means here you will be getting the equivalent resistance across these two terminals, okay. So which is, let us consider, so this is 25 ohms, and again this 25 ohms is in a parallel with the 30 ohms. Then here it is 25 into 30 divided by here 25 plus 30, here it is 55, then you will be having 13.63, 13.63. And here this 13.63 is in series with the 20. So this 13.63 in series with the 20. Okay. So here plus 20, then you will be having here it is 33.63. And here these 33.63 and these 15 ohms are again in parallel. So 33.63 is in parallel with these 15 ohms. Okay. Then here this 33.63 into 15 divided by, here this is 33 and plus 15, so 43 and 48.63. So 48.63. Then you will be get the answer here, it is 10.375. 10.375. Then RAB, which is equal to 10.375. So this is the way to find quickest way. So because now you should analyze within the circuit itself. So every time, of course, in your examination, okay, in a theory examination, you have to draw step by step. Okay, but when you are going to the competitive examination, so it will take you more time if you do one by one step and one by one the reduced network if you draw. So that's why we should imagine, okay, so suppose which means here 15, 15 are in series, then this combination is parallel with the 30, okay, and this combination is in series with the 20, and this combination is in parallel with the 15, then the equivalent resistance must be here, it is 10.375. So like that we are able to imagine, so that we can find the equivalent resistance between the two terminals very quickly. Now there is another problem. So this is also very simple again, okay, because as you can see here, these two combination and again these two combination, right? So these two combination are in parallel and these two combination also are in parallel, right? Then here, then this will be 15 into 60 divided by, here 15 plus 60, here it is 75, so which will be, here it is 12 ohms. Again here, let us find here 45 into 30 divided by, here 45 plus 3, again here it is 75, so here it is 18 ohms. Okay, so which means here it is 15 into 60 by 15 plus 60, here it is equal to 12 ohms. And in this case, here it is 45 into 30 by 45 plus 30, here you will be getting 18 ohms. Then the reduced network will be here, this one, and this is 50, and again here it is 10. Okay, then this will be replaced with one circuit, and this can be replaced with one resistor, and again of course here one more we will be having. So this is 18 ohms, and here it is 12 ohms, and here it is 20 ohms, and here it is 50 ohms, right? Then here 18 plus 20, 30, and 30 plus 20, 50. So again these 50 and 50 are in parallel, of course. Let me write here 25 ohms and 10 ohms. Then 50 and 50 are in parallel, then you will be having here the equivalent circuit like this. Here it is 25 ohms, and here it is 25 ohms, and here it is 10 ohms. Then the equivalent resistance must be, here it is 60 ohms. So here RAB, which is equal to 60 ohms. So step by step we are improving the quick way to find the equivalent resistance between the two terminals. Why? Because here these three are in series. So 18 plus 12, 30, 30 plus 20, 50. Again these 50 and 50 are in parallel. Okay, so 50 and 50 are in parallel, then the equivalent resistance must be here 50 by 2, so which is 25. Again here these 25, 25 and 10, okay, are in series. Then the equivalent resistance must be, here it is 60 ohms, right? So this is the way to find. Again, there is one more problem here, as you can see. So in this we have to find the equivalent resistance between these two terminals. Then here, how to find the equivalent resistance between these two terminals. So here one clear way that we can identify these two are in parallel, because here this point, okay, and here this point are the common nodes for these two resistors. So here these two can be replaced with one equivalent resistance, right? So then here 12 into 6, 72 divided by here 12 plus 6, here it is 18. Okay, then you will be having, here it is 4 ohms. Then let me draw this one. Okay, and is there any another combination? Of course, here actually there are 3 combinations that you can reduce at single time. Okay, so those 3 combinations are, these two are in parallel, here it is 4 ohms. Okay, and again these two are also in a parallel. Okay, so in between these 2 points, again these two can be also replaced, right? And not only these two, yeah, these two can be replaced. Now this combination and this combination and this combination are in series, right? So are in other words, as you can see here, or let me draw here. So then again here, what is 80 into 20? So 80 into 20 divided by 100, then you will be getting, here it is 16 ohms, right? So then how to draw these reduced network? 10 ohms, again here it is as it is, and here it is 5 ohms as it is, and of course here the point A is as it is. Okay, then here, because let us consider here it is the one terminal, and here it is second terminal, and here it is third terminal, right? So, and yeah, I mean up to here it is the terminal 3 only, here also 3 and here also 3, right? Because these all are connecting to the same terminal, right? So then in between 1 and 3 you must replace one equivalent circuit. Okay, so of course here let us consider, here it is 3. Okay, and again one more 1. Okay, so let us consider here the same way. Okay, the same way here I am just without getting any confused. So here it is 1, and again here you will be having one more resistor. Okay, then let me delete this one, and of course this is 2 and this is also 2. Okay, so then again here you will be having in between one more resistor, then here it is B. Okay, so don't get confused, because that's why here I'm just for your better understanding I'm just indicating these nodes, okay, without getting confused. So in between 1 and 3 you'll be having two resistors 80 and 20, so the equivalent resistance is 16, so 16 ohms. And in between 1 and 2 you'll be having the two resistors 12 and 6, and these two are in parallel, then the equivalent resistor here it is 4 ohms. So here it is again 2 and here it is again 2, right? Now as you can see, these 16 ohms and these 4 ohms are in series, so 16 plus 4, which is equal to 20, and of course here it is again 20, and of course here in between there is another resistor which is 5 ohms. So here it is 5 ohms and here it is the point A. Then the equivalent resistance, because which means here the node 1 is we are eliminating. Okay, so then the equivalent resistor must be connected in between what is that, these 1 and 2 nodes, right? Then again here the 10 ohms is as it is, and here 5 ohms is as it is, and here the third ohm is as it is, and then here this is as it is, and in between you are getting one more resistor like this. Okay, so then here it is 20 ohms, and here it is 10 ohms, and here it is 20 ohms, and here it is 5 ohms, and then A and B. Again, as you can see, these 20 and 20 and these 10, these three are in parallel. Okay, these three are in parallel. Okay, then first let us come with here 20 and 20. So 20 is parallel, then the equivalent resistance must be 10. Okay, 10, and this 10 and 10 must be in are in parallel, then the equivalent resistance must be 5. Then the equivalent resistance between these two terminals, okay, 5. So here where the 5 should be, here in the place of 20 you will be having 5. So then here it is A and here it is B. So here it is 5 ohms and here it is also 5 ohms. Then RAB, which is equal to now 5 plus 5, which is equal to 10 ohms. So this is the answer. Right? So in this way, we need to solve the problems. Right? So like this here also it is same. Okay, this problem also. So every problem here, you just solve. Okay, so this problem you just try to solve by yourself. Okay, and again this problem also. You guys just try to solve by using the same procedure which we have followed in the previous cases. Right? So thank you.
Like, share and subscribe. Hit the bell icon for more updates.